Okay, so I think everyone has joined. So I will start from there again. Share. Audible and visible? Hello? I don't know if I'm audible or not.
Yes,
Yes,
sir,
sir,
you are audible.
I'm audible. Okay, great,
Yes,
great, great. Because when I open this shared window, everything disappears and I get confused whether am I audible or not. Okay, so we have created the symbol. Now, once this symbol has been created, we can close this window. Now I want to test whether this symbol works exactly the way the other symbol was working or the other inverter was working or not. So I'll make a new cell that inverter 2 test. I'm just making for you that we are testing the inverter 2 symbol and how to use that symbol. Now you do not need to create the whole inverter again. Press I, go to this library. Now you see there is a library name of Workshop Ashish. You click over here. There is inverter 1, inverter 2. There is a symbol of inverter 2. Right? You close it. Hide. Okay. So it is now showing the whole inverter. We need to get the symbol. So it is picking the schematic. We need the symbol. Symbol. If you pick the schematic, it will copy the whole schematic. If you will pick symbol, it will pick the symbol only. Right? Okay. And there you get the symbol. Right? Here you get the symbol. Now let us test this symbol. I will go now. I will not go to GPDK. I will go to analog library only. I will select ground. There I have the ground. This one. Then I have the V input. There I will have the output, and there I will have the VDD. I just need to give the sources. This VDC source of 0.7 volt to VDD side. You can put the ground with this. The output pin with the out, the way we did an inverter. This, and then the V pulse in the input. 0 to 0.7 is 20 nanosecond and pulse width of 10 nanosecond. And you give a ground. What is the warning it is giving? It is saying that it is very close to this MOSFET. That is of no problem. We'll have ADL, transient analysis, 100 nanosecond, apply, okay. Then we need to give the name into the wire. Let me place it here. Then we say output to be plotted, input, and an output. There you have it. And then you simulate it. See, the similar output you are getting from the symbol. Now, just assume that if the circuit was having 100 transistors, then how space saving, and how less difficult it was to understand. Now, if I ask you to create a circuit with a fan out of 4, uh, uh, any of you know about the circuit of fan out of 4? What is the meaning of fan out in digital? Anyone? What is the meaning of fan out in digital?
Sir, I think the number of output it can drive.
Yes, number of gates that can be driven by the similar gate. For example, if I'm having the AND gate here, how many AND gates it can drive from its output? It is the fan out. For inverter, we will create the fan out of 4 circuit. Fan out of 4 means I want to create a circuit inverter like this. One inverter driving 3 more inverters. This is fan out of 4. How I will create? It is very easy, because now I know how to use the symbol. So what I'll do, I'll copy this symbol. I'll paste it here. Press C for copying. Select plus C for copying, and then copy it here. Then again press C for copying. Place it here. Right? And what I'll do, slightly away from it. Now you see, you need to connect them. For connecting them, remove the output from here, connect its output to its input, the output of this to the input of this, the output of this to the input of this, the output of this to the pin. Right? And what about their VDD? You can join the VDD with the same source. You see. Now you join the gate, ground with the similar ground all around. That's how simple this circuit is. This is a fan out of 4 circuit. Now just imagine the usage of this uh, symbol. You are finding it very simple because it is having only two transistors for one inverter. Just assume that this symbol is having 20 or 40 transistors in itself. Then see how less area consuming the circuit would be. That is how when you create the counters or shift registers in your digital book, you see the counter shift registers having many D flip-flops. If you create a D flip-flop with MOSFETs, it is a huge circuit. But if you create a block of D flip-flop, it will be as simple as that. You are working on a synchronous or asynchronous circuit. That is why the symbols are very important to be understood, and it is very important to understand that which pins are to be kept outside, right? The kind of a block that are given in your book, you need to keep all those pins outside. Now what I will do, please see this carefully. I am going to name output 1 to this, then output 2 here, output 3 here, and this output I will name output 4, right? So when I will use ADL, the input will remain same and output, now I will be having 4 output, output 1, output 2, output 3 and output 4. Output 4 नहीं आया. You see output to be plotted. Select on design. The output 4. It is not picking the output 4. Let me try once more. Now I think it has, yes, now it has checked output 4. Now when I simulate this, this is how it looks like. This is input, this is output 1, this is output 2, this is output 3, this is output 4. You please see every output is the invert of its previous output. Till this point, if you have any question, please ask. If you have any question till this point, please ask. Otherwise, I'll move to the next topic, which is how to compute the delay in the circuit.
Sir, it means delay is also adding.
Yes, that we will see when we will
circuit.
calculate delay. Na? We will see that. When we will do power, I will take the example of one inverter, and when I will compute the delay, I will take the example of all these 4 inverters. Yes, but once you are true in this case, that delay is adding up. You see this. This is input, this is first output, this is second output, this is third output, this is fourth output. So the input was at 20 nanoseconds. The first output is on 20.11, the second is on 20.16, third is on 20.19, and fourth is on 20.22. So every inverter is adding up some delay. But the point is, we cannot rely upon the random values. We need to find the exact value, right? So let us see how to compute the delay. I will take the example of only one output for the first delay. The delay between input and the first output. You go to tools, use calculator, right? In calculator, when you use this tab function, you see a lot of functions over here. In this functions, you use this delay function. When you click this delay function, this sort of a window turns up. It is very important to understand that what these windows say, so that you can do the things by your own. Now this first is signal 1, second is signal 2. The signal 1 is your input signal, signal 2 is your output signal, right? Then threshold value. What is the threshold value? Threshold value is of 50% of your given input. For example, in this you are giving 0.7 volt. So your threshold value for the first signal will be 0.35. And in your output, there is also the maximum voltage is 0.7 volt. So the threshold is 0.35. Edge number will remain the 1. I will show you in your what you say wave shape that what is the edge. Then edge type, it can be rising, falling, or either. When you use the word rising, it takes the delay of the rising pulse. When you use falling, it takes the delay of falling pulse. And when you use either, it takes a maximum of both. Whatever is maximum, it takes. I will give you an example of all the three so that you can use it effectively. First, I will use either this side also. Number of occurrences, single, and rest part you have nothing to do. Now you select the wave from here. And then signal 1. Once you click on signal 1, you go to wave shape. Where is your wave shape? We'll create the wave again. Okay. So this is your red is your input, green is your output. You are here, signal 1, go to wave. Signal 1 is your input, press anywhere on your wave. There you get this. Copy it or cut from here, put it on signal 1 function. Similarly, go to signal 2, wave shape, click on anywhere on your output wave. You get this. Cut from here, put it to signal 2. Now you use the word apply. Once you apply it, you will see that there is a formula of delay comes here, right? And then press this button. It will evaluate the delay for you. This is 53.16 picosecond delay between the first input and the first output. The input and first output, the delay is this. I'll show you the whole process again. And this time we will take the second output. What is the second output? Let us go to the circuit. This was output 1, output of first inverter. Now we are going to the output of second inverter. Remember, we are calculating the delay between input and second inverter, not the output of first inverter and second inverter. We are getting the delay between input and the second inverter. So what do you think? This delay will be higher than the previous delay or lower?
Higher, sir.
It will be higher. It will be higher because आउटपुट वन में तो सिर्फ इन्वर्टर का डिले था. जब आउटपुट टू होगा तो उसमें इसका भी डिले होगा और इसका भी डिले होगा. 4 ट्रांजिस्टर्स का डिले होगा. So we'll see how it goes. This is your wave shape, and then you start doing the same process. Go to tools, calculator. I'll show this process a bit quickly now. You see there is already given 0.35, 0.35. Now you just take the signal 1, go to the wave shape. Signal 1 is input. Here you have signal 1. Put the signal 1 here. Now the turn of signal 2. This is a signal 2 output. This is your signal 2. Where it has gone. Okay. There you have signal 2. The threshold value is 0.35. The rest is same. Apply. There you get the formula. Take the output. Now see the delay. The first delay was 53.16, and between input and second output, the delay is 88.15 picoseconds. Now, any of you who has not yet got what we are doing, I can explain it again for you. Anyone जिसको समझ नहीं आया, उसके बाद I'll get into nitty-gritties of delay. कुछ भी समझ ना आया हो, anyone you did got anything that ये समझ नहीं आया, you ask, otherwise I'll continue. ठीक है, तो फिर let us move further. We have seen that in this process, where is that annotation? Yes, it is here. If you give input from here high, you will get a low here. And if it is low here, it will be high here. If it is high here, it will be low here. If it is low here, it will be high here. Clear with everyone? In inverters chain, it is very clear that if you are having odd number of inverters, then you will be having inverted output. If you have even number of inverters, then you are supposed to have the same output. Means if your input is high and number of inverters is even, the output will also be high. And if your input is high and number of inverters in chain is odd, then output will be low. I think it is very easy to understand. Right? Now, what are the nitty-gritties of delay? Let me close these windows to avoid any confusion. Now I'll come back to the first output of the first inverter. If your circuit demands that you give me the output or delay between the input getting low and output getting high only, then how you will calculate it? Remember, the input getting low and output getting high. When you take the concept of either, when you select either, so it means that whatever delay is the highest, the calculator itself give you the highest delay. But now your examiner or your interviewer specifically wants you to tell you the delay of this waveform when your input is coming down and output is going upwards, right? This delay, how you will calculate it? You will go to calculator. Again, you will go to function. And now you will again select the signal 1 and signal 2. This is your signal 1. And there you have signal 2. Right? So you see this. Now I have taken the two signals and I want, when input is getting low and output is getting high. So in this case, you take H type. First signal is input is falling and output is rising. Apply. You see, this is the delay. This delay is different from what you got. Your question was very specific about that. What if your input is falling and the output is rising? Now my question is opposite so that you can understand it again. I want the input is rising, output is falling. Input is rising, output is falling. Then what will be your output? Your signal 1 is input. This there you have. And signal 2 is output. There. Then you have threshold voltage again, the threshold value same. Now your input is rising, output is falling. Then you apply it. And then see this. This is lower. So in that case, we have seen that we can compute delay. We can compute the delay by not considering any edge or any rising or falling, or we can compute by considering rising or falling. Now you please see one thing very clearly, that In case I take output 2, then somebody wants a case of rising and falling, then the signal 2 is same as signal 1. If they want the delay over here, then input signal is also rising, output signal is also rising. Or the input signal is also falling, output signal is also falling. So it is up to you who is to see that whether you need to select rising or falling. अगर आप गलत select कर लोगे तो output गलत आएगा, right? I hope you got this point that where do we need to use rising or falling. If any of you have not got this point, please let me know. I'm ready to explain this again. Or if you have any query regarding this, please ask. This is a very important concept. When you will create any circuit, you will be requiring to find the delay, and it will be precisely your mindset who will explain that whether you are going to go with the rising, falling, or either edge. It is you who is to decide in your circuit, and you should learn both ways. Now please ask me that if you have any doubts on this, because when I will teach you the concept of delay in theory, then this whole concept would be required. Please ask if you have any specific query on this. Till then, let me have some water.
Sir, I have one question.
Yes, welcome. Please go on.
Sir, initially when we have calculate the delay, not initially, third time when we have calculate the delay, rising and falling, and we are get the value 52 picosecond, right?
Yes.
And the
Yes.
second one we are getting the 53 picosecond. So which one is the correct?
See,
So if we wanted to present it, yes, sir.
if you want to put one value of your circuit, see, there are multiple cases. One is that you want to show that the rising case or falling case separately. If you have to give one value out of those, then you should give higher value, because the rest of your circuit will be dependent on the maximum delay,
Okay, sir.
right? You should always quote the maximum of both.
Okay, sir. So it means we have to calculate in both the way delay in rising and falling and rising.
In larger
So
circuits,
which
Gautam,
one
we
is the
actually
maximum?
calculate with the either way. It gives you the average delay. That also works.
Yes, sir. Okay, but that case only when both the inputs are input and output both are the similar. Then we are going to calculate through the either way.
No, 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 no. Whatever is the input, whatever comes output. If you use the wave shape either, then you are going to get the average delay, and that is taken
Okay, sir.
generally correct in your project tasks.
Okay, sir. Thank you, sir. Done.
Right. Anything else? Any other question? Okay. So shall we move forward to the part of the power, computing the power, or shall we stop here and talk about the power tomorrow? Because we'll be having very different types of power. We'll be talking about the leakage power, switching power, dynamic power. Should we start the topic today, or should we keep it to tomorrow? I am comfortable with both, actually. Okay, so in this particular circuit of four inverters, I give you an assignment to do. If you people are having the Cadence software with you, then you please compute the delay between first input and the second output, the first output, and then according to this input, get the output, second output, third output, fourth output. So your first input will be this V in only. Second input in first case out 1, out 2, out 3, out 4. Then repeat this exercise for considering output 1 as your input, and then out 2, out 3, out 4. And then what you come out of, what analysis you bring out of it, I would be very interested to know, right? Consider this as an assignment that if you can do. Otherwise, I'll get the outputs, and tomorrow I'll explain you that what you can analyze or observe out of these. Because if you do this exercise, actually you would be doing everything that we have done till now, and it will give you a good practice, right? So today we'll stop here only. We'll compute the power tomorrow, and we'll sit together everyone, and we'll compute the power of inverter, and we'll study about the basics of static random access memory. And the day after, we'll be studying a few concepts about delay and power in theory. If we get some time tomorrow, we'll also study a few concepts of power tomorrow with this experimental results. In the next week, I want you. So if you have any Cadence software, or if you can install it from somewhere, please do that, because in the next week onwards, I would expect that we all will do the projects in parallel way. So this week, you please do the practice, and I'll tell you the concepts of delay and this power consumption, the precise theoretical concepts which are required by tomorrow, right? So till then, thank you so much. Good night. We'll meet again tomorrow with new experiment. Thank you. Thank you, everyone. Thanks a lot.
Thank you, sir.